Hello, everybody. Welcome to this edition of an AFT webinar. Today, I want to talk with you all about saving time with transient checkpoints. This is going to be a little bit of a shorter webinar. Mostly going to do, basically everything is going to be done in the software. Going to try to walk through kind of what was the intention behind transient checkpoints, some of the good use cases behind them, a little bit of a walkthrough example of a case you might see, where a transient checkpoint file could be useful, and maybe answer some questions at the end if any pop up. So to kind of hop straight in, I'm going to be using AFT xStream today in order to kind of showcase how these transient checkpoint files work. Checkpoint files were originally created as a way to kind of help users with runtime inside of both our transient solvers, Impulse and xStream. Generally, runtime can be reduced in a model through basically doing different sectioning, different calculations, but kind of as you decrease that sectioning in your model, you tend to decrease the accuracy of your results. So in some models, you can have very long runtimes. For these models, sometimes you're kind of in this model building, troubleshooting phase where maybe a large part of your transient remains the same with the changes you're trying to make. Maybe you're trying to extend a runtime, those sorts of things where you don't want to repeat calculations. This is where transient checkpoint files step in. To stop users from maybe having an hour or 2 hour long runtime, we maybe can't reduce that runtime, but instead of having them, make a small change in their model and have to run it for 2 hours, make a small change, run it for 2 hours. You could take maybe an hour and a half of that runtime and say that's going to stay the same throughout all of my runs. It's just this last 30 minutes of runtime that I'm really making changes in. You can start to save all of your output for that first hour and a half run, and then just start rerunning the last 30 minutes. How you access these transient checkpoints for setup purposes is in the analysis setup. So you click analysis, analysis setup, and then we have this new transient checkpoints tab in Impulse 10 and xStream 3. Here, by default, we have creating a checkpoint file for the last time step. This allows users to extend a run further. If you were looking at maybe something like damping out a wave in a system or line pack in a system, you might want to extend the runtime because you don't know how long to run the model file for. So you might run it, 2-minute runtime, and then you find, oh, I'll need more like a 3-minute runtime. So instead of repeating all of that, you can just take that checkpoint file at the end and finish your run with it. We also have a couple of other types of checkpoint files you can create. By default, there's this on simulation ending error. This one's really useful for troubleshooting model files because you might have an error in the middle of your run and you're not sure what went wrong, why it just stopped in the middle of the run. So with this, you could have a little bit of output. You could restart your run from that error and just try a whole bunch of things in your model file until you can figure out why you're receiving an error. There's also an always option. This is more for if you wanted to save multiple checkpoint files throughout a time step. Maybe you have a transient event and then a couple of seconds after the transient event, you end up crashing the system. So you want to do checkpoint files leading up to that, so you can see, what happened at the transient, what happened just before the error, what happened at the time of error, those sorts of things. Lots of just being flexible with these settings. So here I have a model file set up. This is just a really simple assign pressure going to an assigned flow junction. The assigned flow is just kind of a ramp up sequence of flow rates. And we have this heat exchanger operating in the middle to kind of pull out some of the heat from the system. When I give this model a run, we're going to see it starts chugging along. This is a very short runtime for an xStream model for the sake of the webinar, but you could see if this was maybe 2-3 hours long, this could be a very annoying thing to happen. But an error should pop up part of the way through the model runtime. So here, we received an error occurred while running transient solver, inline k-factor, subsonic iteration problem. That's a mouthful, but this is telling us something went wrong with the calculations. There was a solver error. Not exactly sure what's going on. But when we get to view the output up to that point, we can see that there's this temperature warning saying we fell below the minimum fluid range. That's a little bit weird. We're working with air as our working fluid, so this has to be getting really, really cold for us to be getting an error like that. So we have this partial output. We know that our fluid's getting really, really cold. Not exactly sure maybe what's going on. Maybe you're reading this error message and you're not sure exactly where the problem is. This could be a very big model file. The transient checkpoint file could help you tweak things in a model file here. So we could maybe say, well, maybe my flow rate ramp is too high. You can maybe try decreasing those, see if the error message goes away. You could maybe check your cooling and your heat exchanger, make some of these small adjustments and see if you continue to get that error. What you'd want to note here is any changes you're making into the model file. You're effectively merging two output files. So we have an existing output file for the checkpoint. Anytime you start from a checkpoint running, you're creating a new output file and then we're merging the two. We're going to see an example of that here shortly. But we might try making a change. Let's do something maybe with pressures upstream, just to show what it is, not really meant to resolve the issue, because it's a simple model and we'll see the solution simple. But if we do something, we can then try continue running from checkpoint. Nope. Looks like the checkpoint file cleared when I made that change, my bad. Some things to note with checkpoint files that are kind of fun. One, it'll create a new file inside of the directory with your model file. So if you were to just ship your model file into like our support team, for instance, you'd want to try to grab your xStream file, the output file, and the checkpoint file. And if you email those into our support team, then they can start doing some rapid fire troubleshooting on your model. So if you're really confused on an error message or something, it'll help you get a response a lot faster. So that way we wouldn't have to redo some of your calculations. Also, checkpoint files are scenario propagatable. So if I were to clone the scenario with output, then we could see that a checkpoint file was created. Kind of showing how you can continue a run from a checkpoint because the initial point. Why is that not creating my checkpoint file? Well, get to do a little bit of live troubleshooting. Let's try it with just a straight cancel. Okay, so I'm gonna have to check with our developers on why that wasn't popping up with my error message. But here, this is what you would normally see when you have an error happen in a model file. You get this checkpoint file, and then with those time steps moving down, you can start from this time step. So if we were to continue the run, we could see that, we had 5% before, now it's getting to continue that run file. And that should all be good. So before we were looking at some sort of cooling temperature error that popped up. We will probably want to get rid of that, figure out what's going on. Well, the only thing that's causing cooling is our heat exchanger. So we can take a peek at it and we can look at, we have this negative 460 BTUs per second, which is extremely high. Heat being pulled out of the system. This is very unreasonable. Likely somebody probably wanted to do maybe like a BTU per minute or just a lower heat rate coming out of the pump or out of that heat exchanger. So if we were to fix that, we can see that running the model file. We'll remove that error. We'll be into a better solution state. And we'll see that once this run completes. We'll be able to view our output, potentially extend the runtime, check kind of what our results look like. So kind of have this model file run. We can see that we're at very low mock numbers. So there's some advisory to tell us, hey, we should probably adjust our solver settings. So here we can start to adjust our endpoint. So if we want to try continuing this from a checkpoint, we can see our ending duration was 10 seconds. What happens if we want to bump that up to 11? Model file should run the same. We repeat those calculations, but we just extended the time step a little bit. Yeah. What you might see when you run a checkpoint file is this error message or caution message saying these results were generated from continuing an existing run checkpoint. Some of the warnings may only be relevant for a portion of the run. What this is basically trying to say is sometimes when we're parsing through the data, we'll throw a caution for one of the checkpoint files that you had, but the transient after the checkpoint file might not have the error or might have a duplication of that error. So you could end up in this warning message seeing maybe two of the same warning for the same thing, or you could see it might say that this error existed in this time step, and then later on, the error is no longer there in the system. So this is just kind of telling you to be careful in interpreting your data when you're, because you've kind of made two disjoint output files. So here we had a caution that was telling us our mock number was too high, so we probably want to drop this mock number to be something a little bit better. That is weird. Looks like there's a little bit of a script button. So if we were to drop that mock number to something closer to the original, it clears out our checkpoints, and we can run the model file again to get that full runtime. So changes in the system will clear checkpoint files. You can get them on checkpoint files to generate on errors, and when you hit like cancel runtime, you can extend runs with your you can extend the runtime in your run if you wanted to see additional effects inside of this. So that is most of what transient checkpoint files are used for, kind of how they work. Some different scenarios where you could set them up for the future. Yeah. Are there any questions from anybody in chat? Yeah. Well, currently not seeing any. This is most of what I had for transient checkpoint files. Again, very simple but powerful tool for your impulse and xStream runs. Again, reiterating the use cases is extending runtimes. You can not repeat calculations that don't need to be repeated. You can troubleshoot error messages more effectively. And overall, just have maybe an easier time when you're dealing with those longer runtime models. So thank you everyone for attending, and I hope you all have a good rest of your day.